So we have studied two results. One result which states the distribution of sum of squares due to residuals, and other result which states the distribution of regression sum of squares. Now we are going to combine both these results to prove the justification behind a global or overall f-test. So let me first state the results that we have. So first result we had was sum of squares due to regression when divided by sigma square, that is SSR by sigma square, is nothing but 1 upon sigma square y prime, then x prime x whole inverse x prime minus 1 u prime u whole inverse u prime, this whole thing into y. This is a quadratic form and it follows chi-square with k degrees of freedom, because this matrix we showed is idempotent, and the non-centrality parameter for this chi-square was lambda equal to 1 upon sigma square beta r prime centered x, that is xc prime xc beta r. That was non-centrality parameter. Okay. Then we established similar result for residual sum of squares. So we got SS residual divided by sigma square is 1 upon sigma square y prime identity matrix minus x prime x whole inverse x prime y. This follows chi-square with n minus p degrees of freedom. Okay. We know from distribution theory that the ratio of two chi-squares divided by their respective degrees of freedom follows F distribution. But there is one condition, that these two chi-squares have to be independent chi-squares. So let us now try to see if the chi-squares that we have currently, if they are independent. Okay. So these two chi-squares will be independent if, from the theory of regression, what we know is variance of epsilon is sigma square I, correct? So these two will be independent if I have the product of these three matrices to be 0. That is, if I have the first matrix coming from regression sum of squares is this. So let me write that first. X prime x whole inverse x prime minus u prime u whole inverse u prime into sigma square I coming from variance of epsilon into I minus x prime x whole inverse x prime. So if the product of these three matrices is 0, then we can say that the two chi-squares are independent of each other, and hence the ratio will be F. Now sigma square is a constant, so I can take it outside. It's not a matrix. Then I'll be left with x prime x whole inverse x prime minus u prime u whole inverse u prime into identity matrix minus, because this identity matrix will go away, I x prime x whole inverse x prime. So if this product is 0, then we get something. So let me consider the product. Okay. So what I have is this will be equal to sigma square stays outside. The first thing will be x prime x whole inverse x prime into identity, so this stays as it is, minus the second matrix becomes x prime x whole inverse x, then again x prime x whole inverse x prime. So I am taking product of this with the second entry here, then product of this with the first entry here becomes minus u prime u whole inverse u prime, and the product of second terms from both the brackets becomes u prime u whole inverse u prime into x prime x whole inverse x prime. Okay, so what do I get? So I missed writing one x prime here. We had x prime x whole inverse x prime into from here x prime x whole inverse x prime. So this x prime x and x prime x whole inverse, they cancel each other out. So I am left with x prime x whole inverse x prime with a negative sign. So this gets cancelled with this. Okay, and from the theory of partitioned matrices, when we were dealing with regression sum of squares, I think we had a result that this u prime into x prime x whole inverse x prime is nothing but u prime. We use this result. Okay, so this becomes u prime u whole inverse u prime, and I already have u prime u whole inverse u prime here. So this also gets cancelled with this, and hence I am left with 0. Thus, we have proved that these two chi-squares are independent. Hence, if I take their ratio after dividing them by respective degrees of freedom, then I'll get f with corresponding degrees of freedom. So what do I get? Let me write. For SSR, the degrees of freedom are k, and for SS residual, the degrees of freedom are n minus p. So what we will have is this. So SSR divided by sigma square, and this divided by the degrees of freedom. So divided by k into numerator I will have SS residuals divided by sigma square divided by its own degrees of freedom, that is n minus p. This follows chi square with k comma n minus p degrees of freedom, and that lambda is the f, because we have ratio of chi squares now. So f with k for comma n minus p degrees of freedom, and lambda as non-centrality parameter. Now we know SSR by k is our MSR, mean sum of squares due to regression. Okay, so I have MSR, sigma square from both the terms gets cancelled. MSR divided by MS residual will follow f with k comma n minus p comma lambda. Now what was our lambda? Our lambda is 1 upon sigma square beta r prime. So beta r prime means the coefficients corresponding to regressors, then xc prime xc beta r. So when I want to test under h0, all my betas are supposed to be 0. When I want to test for overall regression under h0, all betas are supposed to be 0. Hence my beta r vector becomes a 0 vector, and my non-centrality parameter becomes 0. So under h0, MS regressor divided by MS residual follows central F distribution with k and n minus p degrees of freedom. Hence our cutoff for this global or overall F test comes from central F, that is our usual F. Okay, so this establishes why we use F or ANOVA type test for testing overall usefulness or significance of the regression model. Okay, let me stop here. Thank you.